Guys, it's day 87, 14th last day of the 100 Days of LeetCode. We got a medium problem. It's validate binary search tree, all right? We're given the root of a binary tree, and we want to determine if it is a valid binary search tree, BST. A valid BST is defined as follows. So the left subtree of a node contains only nodes with keys less than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. Both the left and right subtrees must also be binary search trees. Okay, so it's an interesting problem, right? One thing we need to know right away is that we can't simply just check whether or not the value of the left child is less and the value of the right child is greater. We can't do that because it doesn't take into account the possibility of a situation where, let's say this was greater. Well, over here to the left, we could still have a node that's smaller and it would still be an invalid tree, right? But if we do that method that I just sort of spoke about right now, it would of course be the algorithm would be wrong, right? So we need to find a way to check the entire tree. Now, one way we can do this, and it's the way that I'm going to be doing today, and I'll link a video in the description below about the binary tree in-order traversal. What we can do is we can do an in-order traversal, and then we can check whether or not a list that we keep during the in-order traversal is sorted or not. So what an in-order traversal is it's a way to traverse a tree in order. And what that means is that we simply visit we go all the way down to the left of the tree, and then we just visit the nodes, left child, root, right child, okay? And then we continue that throughout the whole tree. So in this tree, an in-order traversal would look like this. We would first visit this node, we would visit that node then we would go and visit this node, and then that node, and then that node. And we'd have a list, and we'd check whether or not it's sorted. In this case, of course, it wouldn't be sorted because it'd be 1, 5, 3, 4, 6, and we'd return false. Now, so we just want to write the code now. So let's do it. First, we're going to create a in-order method. I mean, you could probably do this all in one method, but I don't know. I like creating sort of separate methods like this. So let's do that. We can just create a root, and just for consistency's sake, let's define it as an optional bool, and not even for consistency's sake, because sometimes we might have a none. Okay, so in order to do an in-order traversal, what we need to first do is we need to check whether or not the root exists. So what we can do is we can say if not root, meaning that if root is equal to none, well, of course we just return. We don't want to do anything with that, right? One thing I forgot, guys, I'm going to go back up here. This needs to take a list as a parameter as well, so we're going to just put in the list. Okay, so now we've checked that whether or not there's a root. Let's say there is a root. Perfect. Okay, so like I said, the way we do an in-order traversal is we first traverse the left subtree, then we come back to the root, then we traverse the right subtree. So what we do is we say, okay, we are going to call self.inOrder of root.left, pass in the list, and then we're going to come back to the root, right? So basically when we visit the root, we're just going to append root.val to the list, and then we're going to do an in-order traversal of root.right, the list. Okay, so that's how we do that in-order traversal. Any single sign, root.right or root.left is none. It's just going to come into the method, and of course, it's just going to return here. So we're not going to be adding to the list in any of those situations. Now, the rest is pretty straightforward. In this method, what we need to do is we need to create the list. We'll make it empty. We'll call self.inOrder on root, pass in the list. And then this is a neat little bit of code. There is a possibility that even if the list is sorted, it might still not be a binary search tree. So a binary search tree, by definition, cannot have duplicate values. So we need to basically convert our list into a set and make sure that it lost no values. So set is like a list, but it doesn't have any duplicate values. So if we convert our list to a set, if there are any duplicate values, they'll get thrown out, and we'll basically be able to tell whether or not it's a valid tree. So what we can do is we can just say the list, if the list is equal to list, or excuse me, sorted, right? Because we want sort of this list inside here to be sorted. List set the list, right? So first we convert the list to a set to get rid of, excuse me, any potential duplicates. Then we convert it back to a list just to get it the same type. Then we sort it. And then if we're in here, we can return true. But if we're not in there, then we know that something went wrong in our Inorder Traversal and we do not have a sorted list. Or we do have a sorted list, but there are duplicates. Any case, we have to return false. So we can now submit our code. There you go. So that's one way to solve that problem. That was day 87. If you guys like that, please like, subscribe. We'll be back tomorrow with day 88. Take care.